Hello and welcome to another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 10, Lesson number 4, on variation within a data set. Before we begin, let me remind you that you can find a worksheet and a homework assignment that go along with this video by clicking on its description. As well, don't forget about the QR codes on every one of our worksheet. Take your smartphone or your tablet and scan that code, and you'll be brought right to the video that goes along with its lesson. Alright, let's begin. So far we've talked a lot about measures of central tendency. Well, maybe not a lot, but we talked about them in the last lesson. And a measure of a central tendency is a statistic, okay? Singular, statistic, all right? That gives a central value that's representative of the entire data set, right? And we had the mean, and that was the average, right? That could be affected by things like outliers, so it could be a little bit deceptive. And then we had the median, which was the center value, the one right in the middle. And although those are great in terms of sort of summarizing, the big piece, and you've all heard teachers come into a room after a quiz and say, hey, the average value was an 82 on this test, right? And that tells you something, right? It tells you something. But there's so many more statistics out there. And the thing that we're going to be looking at today are measures of variation. Measures of variation, right? You know what variation means. It means things that are varying, right? Things that are changing, right? And a measure of variation is a statistic that gives an indication of how spread out the data is. I mean, is it really all very close to the mean and median, or is it really, really spread out? You've seen a measure of variation so far, and the only one you've seen is the range. And the range is so-so in terms of a measure of variation, right? That's the max versus the min. And the range is definitely helpful. It's nice to know, hey, the range in temperatures today was 54 degrees. The problem, though, with the range is it can very much be affected by outliers, right? Especially if there's like a very high outlier and a very low outlier. It'll make it seem like there's a huge range, which makes it seem like there's a huge variation within the data set, but maybe all the rest of the data is really quite closely grouped together, all right? So today we're going to look at two types of variation, all right? And the first one that we get into is in the first problem. So I'm going to clear this out, and let's jump into it. Now, right away we're going to be needing our calculators, and I'll bring out the TI-84 Plus very quickly. It's going to be important for us to know how to use it in this lesson. But let's take a look at the first exercise. The two data sets below each have equal means. So if we added up all the values and divided by how many there are, they would have equal means, but differ in the variation within the data set. Use your calculator to determine the interquartile range. Use your calculator to determine the interquartile range, also known as the IQR, of each data set. The IQR is defined as the difference between the third quartile value and the first quartile value. So let's write down its equation right here. In fact, please make sure to do this. The IQR is the third quartile minus the first quartile. Now you might say to yourself, isn't this just another range? It's just instead of the max minus the min, it's Q3 minus Q1. Sure, but this isn't going to be affected nearly as much by outliers, if at all, right? What this really does is it shows you how much of a spread there is in the middle 50% of the data, right? Remember, that's what lies between Q1 and Q3 is the middle half of the data as opposed to the lowest quarter or the highest quarter. You got that middle half, all right? But we have an important task on hand, which is how in the world do you do statistics on your calculator? Now, your teacher may have already shown you this in previous lessons, but let me show you how. So, we're going to open up the TI-84 Plus now. Excellent. And for the first time in a long time, we're not hitting the y equals button. All right. What I need to do is show you how to put data into your calculator. So, what I want you to do is find the stat button. Okay, it's right up here. Found it? Let's hit that stat button. Now, what's nice about hitting the stat button is that the first thing that you see in terms of these menus up above is what's called the edit menu. And that's what you want to go into. So hit enter. Now, your calculator might be completely clear. Mine's got a little bit of data in it, and I wanted it there on purpose. Because what we have here are what are known as lists of numbers or lists of data. So you got L1, which is list 1, L2, list 2, L3, list 3, all right? And what I want to do is I want to clear the data in list 1, okay, get rid of it, and I want to put that data set there. Okay? Now the way I clear it is I bring the cursor up until L1 is highlighted, and then I don't hit the delete button. You hit the delete button, the list just vanishes. Not for good, but it kind of looks like it does. What you do is hit the clear button right here, clear, and then you hit enter. And all that data is now gone. Okay? So, what we're going to do is we're going to put that data set in there. So let's do it and let's be very careful. Ready? All right, so I'm going to enter the 3, then hit enter, then another 3, then a 4, and a 4, and a 5, and a 5, and a 6, and a 6, and a 7, and an 8, and an 8, 9, 9, 10, 10, and 11, and an 11. Now, this is even more important than when you do work with y equals, because when you're doing graphing work, if you put something in incorrectly, oftentimes there's these like little red flags that you can know you put it in incorrectly. With data, there's no way of knowing. So really, you want to go back once you've entered the data, and you want to make sure you did it correctly. All right, assuming that's right though, let's go, because I don't want to take up too much time on the video, let's go over to data set 2. Okay, let's put that one in. We're going to put in 5, 5, 6, 6, 7, 7, 8, 8, and 9, 9. Again, once I've got all that data in, what I want to do is take some time to really check it over. Okay? All right, looks good. So now, let's figure out how to use the calculator to find all sorts of cool stuff, but most important to this problem are the first quartile, Q1, and the third quartile, Q3. So, what I'd like you to do, right from here, hit the stat button again. All right? So you've hit the stat button. And now what you're going to do, I'm hitting the stat button down here, you're going to go over to the calculate menu. And luckily, the first thing that you want, the first thing that you need is what's called one variable statistics, or on the calculator, one var stats. All right? So what I want you to do is hit enter on that. Now, right now though, the calculator doesn't know what list to do the statistics on. I would love for it to be able to do the statistics on both sets immediately, but we can't do that. We have to say one variable statistics on L1. So once you have that up, you want to then type in L1. You can get to the lists. They're right above the 1, 2, 3, 4, 5, 6 button. So I'm going to hit second 1 to get L1, and notice it says now one variable statistics L1. Now I hit enter. And look at the craziness that comes up on the screen. Craziness. A lot of which you can't even interpret. One thing that you can is that little n equals, right? That n equals tells you how many data points are there. How much data did you enter? But what we're looking for is Q1 and Q3. So what I'm going to do is I'm just going to use the sort of the pan down button, if you will. And eventually what I find that Q1 for this particular data set is 4.5. And Q3, notice you also see the mean and the median. Well, you see the median. And Q3 is 9.5. And therefore, the IQR is the difference, 9.5 minus 4.5, which gives me 5. All right, that's it. Isn't that quick though? You're probably thinking to yourself, why did you force us to figure out Q1 and Q3 by hand before? That's kind of important, just to be able to do it. If we had a large data set, this is how I do it every time, or more appropriately, I use a spreadsheet. Anyway, let's do the same thing for L2. All right, L2 definitely has less variation, right? Same mean, but less variation. So what I'm going to do now is I'm going to hit the stat button. I'm going to go over to calculate. I'm going to hit enter on the one var stat. Now that I'm out at the main screen, I'm going to hit second 2. Okay, and what that does is that puts in L2. Okay, but now it says one var stat L2. so I can hit enter again. All this craziness, by the way, just this as a side note, that little x with a line above it, that's the mean. Statisticians call it x bar, all right, but that's the mean, that's the average. All right, so in case you ever need to figure out the average, that's not what we're doing here today. But anyway, if I pan down, keep using that down arrow, eventually what I see is that Q1 is a nice 6, Q3 is 8, and so my interquartile range is 8 minus 6, or 2. And again, notice what these two things are doing is they're indicating spread. So these both had the same mean, and yet data set 1 had a much larger interquartile range because its data was spread out more. It's not because it has more data values, although that is true, but it's because the data is simply spread out more. All right? There was a lot on this sheet, even though there's not a lot of writing. So pause the video now and write down anything you need to. All right, let's do it. Here it goes, clearing out. Now, the interquartile range is an important measure of variation. But the one that is used more than any other is what's known as the standard deviation. I'm going to do it in red because it's so important. The standard deviation, all right? And we're going to talk about what the standard deviation is in a second. I want to show you first, though, how to use your calculator to find it, okay? And then we'll talk about what it means. Now, luckily, we don't have to re-enter the data. We don't have to do that. We do have to redo the whole one var stat thing, but that's pretty quick, okay? So since we've already got the calculator up and out on the screen, let's hit the stat button again. Let's go over to calculate. Let's choose one var stats. And let's tell it L1. Okay, so I'm going to pause for a second. Hopefully you're keeping up with me, but I know this is new stuff. So hopefully on the main screen now it says 1 var stats L1. And now you hit enter. And what you're looking for is a little symbol that looks like this. This is actually the Greek lowercase sigma. Okay? Later on, we're going to also talk about what's called the sample standard deviation. That's S with a little x on it. But this is the standard deviation. We want to round to the nearest tenth, and for data set 1, that's 2.7. All right. Try to find it for data set 2. See if you can go through all those keystrokes again, okay? Pause the video now. All right, well, let me go through it. I'm going to hit the stat button. I'm going to go over to calculate. I'm going to go to one var stats. I'm going to put in L2 now. And I'm going to hit enter. And again, without knowing anything about what they are, the sigma for data set 2 is 1.4. Notice, lower than this. Right? So, great. We've figured out how to use our calculator to calculate a statistic that literally seems to have almost no meaning to us. So, what I'm going to do is I'm going to clear this out, and on the next screen, we're going to talk exactly about what this means. Okay? So, I guess copy down anything you need to by pausing the video. Okay, here it goes. The standard deviation. The standard deviation of a data set tells us, on average, how far a data point is away from the mean of the data set. The larger the standard deviation, the greater the variation within the data set. All right, so it's kind of cool because let's say that you took a collection of 2 weeks worth of high temperatures and you said, well, the average high temperature is 72 degrees Fahrenheit with a standard deviation of 6 degrees Fahrenheit. What that would mean is, the average is 72, but if I picked any data point at random, we would expect it to be about 6 degrees away from that 72, either above or below. That's all, either above or below. Okay, so the standard deviation tells us, on average, how far a data point is away from the mean. Its formula is kind of a beast. All right, for those people that work in statistics a lot, it's not, but they get to like understand the formula and use the formula a lot. And we're not going to do that. What we're going to do is find it strictly on our calculators and work with interpreting it. Okay? So let's do that. Exercise 3. A farm is studying the weight of baby chicks after 1 week of growth. They find the weight in ounces of 20 chicks, and the weights are shown below. Find the mean, the interquartile range, and the standard deviation for this data set. Round any non-integer values to the nearest tenth. Include appropriate units in your answer, and give an interpretation of the standard deviation. Whew, there's a lot here, and yet we've done every single thing in this except for maybe that interpretation piece. So what I'd like you to do now is pause the video, go into your data set, clear out L1 at least, maybe L2 as well, enter that data carefully, and then use your calculator to find those 3 things. All right, and then we'll go through it. All right, let's do it. So, we've still got the calculator up on the screen. All right, we haven't put it away because we keep having to use it in this lesson. Let's go into our stat. Now we go back into edit. Let me review for you how you clear out L1 and L2. That's really important. I'm going to go up and highlight L1, and I'm going to hit the clear button and then enter. Presto magic, it's all gone. I'm going to clear out L2. We don't really have to, but it doesn't need to be there anymore. So I'm going to go up, go to L2, hit clear, hit enter. All right, back to L1, okay? So I'm going to put in 2, 1, 3, 4, 2, 2, 3, 1, 5, 3, 4, 4, 5, 6, 3, 8, 5, 4, 6, and 3. All right, and as always, really critical to check the data over. You know, I tend to enter it and then go back and I like literally almost re-enter it. I mean, I don't re-enter it, but I am 2, 1, 3, 4, etc. Because any mistake here and every one of your answers is wrong. Every one of your answers. All right. But once we're confident that we've got the data in correctly, we're good to go. We're ready. So here's what we're going to do. We're going to hit that stat button again. We're going to go over to calculate. We're going to select one var stats. All right. That pops us back out to that main screen again. And since the data is in L1, we're going to hit second L1. All right. And hit enter. Wow. And there's all that garbage again. Now, the mean, right, is that X bar. Okay, so all we have to do is literally look at it and say, oh, well, the mean is 3.7. And again, since the weights are in ounces, the mean is in ounces. So the average weight is 3.7 ounces. We could figure out easily the median here because they have it, but they didn't ask me for it. They want the interquartile range. And for that, I'm going to need the values of Q1 and Q3. So let's find them. Let's pan down until we find Q1. Q1 for this data set is 2.5. Q3 for this data set would have been 5. Now those would have actually been hard to find by hand because we would have had to have rearranged the data in ascending or descending order, right? In increasing or decreasing order. That would have been kind of a pain. The calculator doesn't care. So the interquartile range is going to be 5 minus 2.5, and that's 2.5. And again, units are ounces. All right. Finally, the standard deviation. This is simple enough. We just look at the screen. You don't need that little X down here, but you certainly can have it, and that's 1.7, and it also has units of ounces. All right. Now, the last thing they asked me to do is to interpret that standard deviation. So here it goes. On average, any given chick, let me put weight. any given weight will be 1.7 ounces away from the mean. And actually, I think I would have preferred it had I rewritten it as, if you pick any weight, it will be on average 1.7 ounces away from the mean. Now, some weights are farther from the mean. Some weights are closer to the mean, right? Those fours are very close to the mean, right? But those ones are quite far away. But on average, a given data point is 1.7 ounces away from the mean. All right? So for now, I think we can put away that TI-84 plus. Let's do it. Okay, so TI-84 plus is gone. I'm going to clear out the text, so pause the video now if you need to. All right, here it goes. It's all clear. And let's move on to the next problem. Okay, now this is a classic statistics problem. A marketing company is trying to determine how much diversity there is in the age of people who drink different soft drinks. This makes sense. You know, if you've got a soda company like Coca-Cola or Pepsi, you know, they want to know, like, okay, well, what's the age range of people that drink our soda? You know, what's the typical mean? You know, what is the diversity? Is there a lot of diversity, or are they all kind of grouped together? So anyway, this marketing company, they take a sample of people and ask them which soda they prefer. For the two sodas, the age of those people who preferred them is given below. So in other words, for soda A, right, there was an 18-year-old that preferred it, a 16-year-old that preferred it, a 22-year-old that preferred it, etc. For soda B, there was a 25-year-old that preferred it, a 22-year-old that preferred it, an 18-year-old, etc. All right, the first question is just a very basic one. Explain why standard deviation is a better measure of diversity in age than the mean. All right, well, this really is almost just gets to the difference between central values and variation values. The mean only measures the central value or the central tendency. The standard deviation will tell us on average how far data points are from the mean. Lots of writing in statistics. All right. Letter B, and this is just a complete eyeball thing. Which soda appears to have a greater diversity in age of people who preferred it? How did you decide on this? So take a look at those data sets, right? Just with your eyes, just kind of look at it, and you know, take a look and see, well, which one seems like it has more diversity. Okay, pause the video now and really take a look at the two. Yeah, so to me, it appears that soda A has greater diversity. And again, anything that you really write down here is fine in terms of how you came up with that. I hope you didn't say soda B. But soda A has greater diversity. For me, you know, it's got a max age of 40, and that's supposed to be the word and min of 16. You know, whereas soda B, no, you know, the maximum age for soda B is 30 and the minimum age is what, 18? Now what's interesting is I'm making that argument purely based on the range, right? Just maximum minus minimum. But now let's prove it. Letter C says, use your calculator to determine the sample standard deviation, normally given as S sub x, for both data sets. Round your answers to the nearest tenth. Did this answer reinforce your pick from B, and how? All right. So, yet again, we've got to bring up the TI-84 plus. Let's do it. All right. And we've got to put those two data sets in. We could put one in L1, do the data, then clear it, put it back in L1, but I'm going to put one in L1 and L2. What I'd like you to do, though, is pause the video now and work through that for yourself, okay? All right, let's go through it. We're going to try to go through this quickly. I'm going to hit the stat button. I've still got the data set in there from the last problem. So I'm going to go into edit, and I'm going to have to clear out what's in L1. So go up to L1, highlight it, hit the clear button, hit enter. Here we go for soda A. Put in 18, 16, 22, 16, 28, 18, 21, 38, 22, 29, 25, 44, 36, 27, and 40. Okay? As usual, you really should spend some time thinking about these, making sure you got them right. I'm going to move more quickly. I'm going to move into soda B, into L2. So let's go over to L2. It takes a little bit to get back up to simply the top of it, but let's pop over into L2. All right, and let's do it. Let's put in 25, 22, 18, 30, 27, 19, 22, 28, 25, 19, 23, 29, 26, 18, and 20. Again, check them out. Make sure you entered them correctly, because then we're going to be ready to run some statistics. All right, if we're sure we have them, let's hit the stat button. Let's go over to calculate. We'll do it for soda A first. And now we're going to hit 1var stat for L1 and enter. Now we're going to talk about this in a second, but since these are samples, we do not use the sigma anymore. What we use is a little s. That's the sample standard deviation with a little x on here. And for A, the sample standard deviation was, where is it? I certainly can't do this in my head, 9.1 years. Okay, let's do it for B now. Okay, so we can hit stat, go over to calculate, 1var statistics for L2, and enter. And our sample standard deviation there is 4.1 years. Now, again, just to make sure, did this answer reinforce your pick from B? Why, yes. And how? Because A had a larger standard deviation. In fact, again, just to hammer home the idea of standard deviation, right, we can interpret this by saying, well, the mean is what it is, right? But on average, a given data point will lie about 9 years, let's say 9.1 years away from the mean. Versus B, a given data value will only lie about 4.1 years away from the mean. All right? So that's it. Lots of data entering. We're going to get rid of the TI-84 Plus now. All right. Pause the video if you need to. Copy down any text. All right. Let's clear it. So let's go on and do one more problem. Oh, but first, let's talk about samples versus populations. I got a little bit ahead of myself. So again, we've talked about this a bit, right? When we can work with every possible data point of interest, and I must say that is rare, okay? I mean, it is really rare when we have a population, but sometimes we do, right? If I was just, if I was giving a test at Arlington High School where I work, and I gave the test to all 600 freshmen, okay, all of them, then I would have that population, the population of people who took that test, all right? And then I would use the population standard deviation to get a sense for the variation. On the other hand, if I had those 600 students and I wanted to just take a sample of 50 of them, a fair sample hopefully, right? Then I would use the sample standard deviation, the S. Now, for the record, the formulas used for those two are just barely different. They're just barely different, okay? So in large data sets, like what I was talking about, 50 people, 600 people, there's almost no difference in the values. And you can see that really well if you just compare them in any situation. But in smaller data sets, it can make a difference. So you should always pay attention to whether you have samples or populations, and look, if you have to err on the side of caution, go with the sample, because 9 times out of 10, that's what you're really working with, is not a population, but a sample. Anyhow, let's do one more problem. So exercise 5 is kind of cool. It says, which of the following data sets would have a standard deviation, the population one, closest to 0? Although honestly, I could have also said sample. It really wouldn't have made a difference. Do this without your calculator. Explain how you arrived at your answer. Okay, so which one of these would have the smallest standard deviation? All right, let's take a look. Well, the plain fact is the majority of these things have a fair amount of variation in them, all right? But not this one, right? Look at those values, 11, 11, 12, 13, 13. There's very little variation here, very little variation. It doesn't matter that the values here, 11, 11, 12, 13, 13, are generally higher than these values. This data set has a much larger variation than this data set. This barely has any variation at all right? So that's why we would go with that one. Okay, I'm going to clear this out, all right? So pause the video if you need to. I doubt you do, but... All right, here we go. Let's finish up the lesson. So today, we studied measures of variation. How spread out is a data set, right? Range was one of those things that you already knew. Interquartile range, being Q3 minus Q1, is a better measure of variation than overall range. But the best one that's out there is standard deviation, and it measures, on average, how far a data value lies away from the average. I know that's a little bit weird. It's like an average within an average, but it is what it is. For now, I'd like to thank you for joining me for another Common Core Algebra 1 lesson by eMath Instruction. Until next time, I'm Kirk Weiler. Keep thinking and keep solving problems.